Niniejszy kurs został opracowany w ramach projektu TEFFIC, finansowanego z programu Erasmus+ i udostępniony do tłumaczenia i celów edukacyjnych w projekcie Nauczyciel 4.0, realizowanym przez Fundację Platforma Przemysłu Przyszłości oraz International Development Norway ze środków programu Edukacja i norweskich mechanizmów finansowych.
Welcome to the 11th element in the TEFFIC series of pedagogical elements supporting the training for Industry 4.0. In the last video, we studied the principles of flipped learning. In this TEFFIC video, we will look at simulators as learning tools and what is important for successful simulator training. Industry 4.0 is driven by the development in a set of key technologies and models for organizing industrial businesses. Specifically, the connectivity of modern computer communications is a major driver of the trend. In the technological domain, simulators have been used for decades. There are a multitude of simulator tools that cover the technologies highlighted as Industry 4.0 drivers. Digital twins are a more recent concept that describes systems that simulates the behavior of complex physical systems. This with a degree of fidelity that approach the real thing, often based on inputs from real-time data from their physical sibling. Integrated cyber-physical systems also allow for simulations of working models and organizational forms. One typical example of this is simulation of lean principles in cyber-physical factories. These simulated systems are an excellent starting block for learning by simulation. But there are some factors that must be taken into consideration when designing a learning process based on the use of simulators. The first, and maybe the most important factor, reported by several studies, is that learning is a social phenomenon. The simulator systems and working methods in the learning process that shall be applied must allow the students to collaborate. Another important factor is that the learning process must be centered around the learner and not the technology. It is also strong indications that collaborative learning is efficient if the participants engage at an advanced taxonomical level. In a case study by the Norwegian University of Science and Technology, where lean principles was trained in a cyber-physical factory, the experimental learning cycle was successfully used as a model for the learning process. This sets the simulations in context and facilitates an iterative process where collaboration, reflection, and application of the lean principles take place. To sum up, simulations may be efficient learning tools if the learning process is collaborative, learner-centered, and involves problem-solving on a more advanced taxonomical level. After you have finished this video, take some time to reflect and to find solutions to this task. How can you apply simulations in your subject, and how can you do this in a learner-centric manner? Our next and final TEFFIC video will look back and wrap up the complete TEFFIC educational framework.